Okay, the directions are to find and identify extrema and state whether they're minimum or maximum. Number 24, we're given the function and its derivative values. Alright, so critical points occur when the derivative is 0. So here, here, and here. And so those are my critical values, but now, what are they minimum or maximum or any kind of extreme? Well, are they minimum or maximum? So here, we do the first derivative test by looking at numbers, the value before and after. It goes from positive to negative. So essentially it goes up, hits the 0, and comes back down. So this is a max. Here, we're going from negative, which means it's decreasing, hit the 0, and then increasing. So this is a min. This one, it's going up, levels off, and it's continuing to go up. So this one's neither. All right. So we have a max. We have a max at -4, 4. Of course, these are locals. And we have a min at 0, 0. And that's the answer, number 24. All right. 25. Now in this one, we're given different values. We're given second derivative. Also, even though this is a critical point, we're not given anything information before that. So we can't use the first derivative test. We're required to use the second derivative test. Well, anyway, what I'm going to do is circle the critical values first. So here we have a critical value, right? Because the derivative is 0. Here we have a critical value, and here we have a critical value. All right, critical values are candidates for extrema. All right, so what do we got? All right, so the first derivative is 0. We're going to do a second derivative test. The second derivative test says if the second derivative is negative, which means it's concave down, then that has to be a max. So by the second derivative test, that's a max because it's concave down, right? So that leveling off point has to be a max. Here, the second derivative test fails or is inconclusive because if the second derivative is 0, then that doesn't tell us anything. However, there's information available for this one, right? It's decreasing, then increasing. So it's decreasing, then increasing. So this one's a min. Here, we can't do this first derivative test on this one because we don't have any information here. However, we do have the second derivative, and the second derivative tells us it's concave up. So this is also a min. That's kind of weird. Okay, so that's a min. So we got 2 mins in a row. How weird is that? All right. Oh, you know, I made up this problem, so maybe it's not supposed to make sense. Well, there are some unknown things going on, so maybe there's something weird going on. All right. This is increasing. I think this is just a contradiction, but we'll just go with the information they're given. So this is probably just a lousy problem. Okay, so we have a min, or max rather. Max at -2, 4. We have a min at 0, 0. And we have another min at 2, 5. All right, I'm looking at the ordered pairs here. These are the ordered pairs of the points. One could argue that this is a bad problem because these 2 mins in a row is kind of strange, right? And it was increasing before it hit there, so how can it be a min? So we're missing other information. Okay, now we're not told anything going on in here, so this is just a bad problem. Okay. All right, moving on. Actually, let's stop there.